Welcome to this explainer on the latest black hole physics. You know, for decades, we've kind of just accepted this idea that the center of a black hole is the universe's ultimate dead end, a place where matter gets crushed to an infinitely dense point and all the laws of physics just pack up and go home. But what if that's entirely wrong? Today, we're going to reframe how we look at the center of a black hole. We aren't looking at a dead end. We are looking at the ultimate unsolved cosmic crime scene. By decoding some cutting-edge mathematical models and quantum theories from recent research, we're going to reconstruct exactly what lies in the dark.
So I want you to imagine, just for a second, that you're falling past the point of no return, the event horizon. What actually happens to you? Do you meet a quiet, inevitable drop into an empty abyss, stretching out like a noodle until you fade away? Or do you immediately crash into a violent, fiery end? To answer this, we have to look at the clues left behind by the greatest minds in physics and some really surprising new suspects that have just entered the lineup.
Section 1. The Event Horizon Enigma.
Okay, so our first piece of evidence is the absolute foundation of our understanding of black holes, the Schwarzschild metric. Now, on the outside of the black hole, Einstein's equations work beautifully. They perfectly predict the orbits of stars, the bending of light, the whole shebang. But the second you cross that event horizon, the math becomes a literal nightmare. It's like a catastrophic computer crash, where reality itself blue screens and just spits back infinities and paradoxes.
Because inside the horizon, according to the math, the radial and temporal coordinates literally swap. Space becomes time. And what does that actually mean for our falling observer? Well, it means that falling toward the center of the black hole is no longer a direction in space. It's an absolute inevitability in time. Just like you can't stop tomorrow from arriving, you can't stop yourself from moving toward the center. The singularity is no longer a where, it is a when, your completely unavoidable future.
Section 2. The Information Paradox.
Back in 1975, Stephen Hawking proved that black holes actually leak radiation and slowly evaporate over time. But his calculations, which you can see represented by that straight green line shooting upward, suggested this radiation was totally random. It contained zero information about what fell into the black hole. That would mean when the black hole evaporates, the information is permanently destroyed. But here's the catch. Quantum mechanics strictly forbids information from being lost. Enter the Page curve, that purple line you see bending downward. Don Page argued that if the universe makes any sense at all, the entanglement entropy, basically the amount of hidden quantum data, has to eventually go down. The information absolutely must be conserved and sneak out in the radiation. But how?
Section 3. The AMPS Firewall.
Now, if information really is conserved and sneaks out, it triggers a massive consequence, the AMPS firewall. See, to save the laws of quantum mechanics, a strict literal wall of high-energy particles has to exist right at the event horizon. Breaking that quantum link with the inside of the black hole releases an enormous amount of energy. Remember Einstein's no-drama rule, which said crossing the horizon should feel like floating through empty space? Well, the firewall absolutely incinerates that rule, along with anything falling in. So much for a quiet drop, right?
Section 4. The Wormhole Resolution.
Okay. Take a look at the left side here. We have the old idea, the Hawking saddle, where black holes just evaporate completely independently. But the math dictating the Page curve revealed something totally astounding for the post-Page time period. The period after the black hole is half evaporated. The actual topology of space-time shifts. Over on the right, you see the replica wormhole. The interiors of the black holes literally become connected. This non-trivial topology proves that the inside of the black hole is secretly stitched to the outside radiation through these hidden space-time bridges.
And here is where all the puzzle pieces snap together. Researchers figured out that the mere presence of this replica wormhole topology naturally alters the space-time geometry. If you calculate the forces for a particle falling into this connected spacetime, a massive, localized mathematical spike called the Dirac delta force appears exactly at the event horizon. The geometry itself generates a wall of force that's proportional to the particle's energy. The wormhole literally creates the AMPS firewall. It's this beautiful, elegant resolution that solves both the information paradox and the firewall debate in one fell swoop.
Section 5. Inside the Spinning Void.
Now, as fascinating as quantum firewalls are, we have to remember that real black holes out there in our actual universe are spinning. While that static Schwarzschild model is great for textbooks, the Kerr metric is what models reality. Almost everything in space rotates, and black holes are no exception to that rule. But mapping the interior of a spinning void requires a vastly more complex mathematical approach.
In fact, for decades, determining the internal geometry of curved black holes has been one of the most profound, stubborn, unsolved problems in classical general relativity. Well, until recently.
So let's dive into an incredible mathematical breakthrough by researcher Yuqing Chao. Using this really novel approach involving ellipsoidal coordinate transformations, Chao developed a physically plausible interior solution for spinning black holes that just works beautifully. First, it preserves the well-tested exterior metric perfectly. Second, it's super elegant, relying on just a single free parameter, the mass. Third, it completely avoids the need for any impossible exotic matter near the horizon. And finally, it ensures finite tidal forces, meaning the math doesn't just blow up into impossible infinities.
So what is actually inside this spinning void? I mean, if there's no infinite singularity, what replaces it? The math points to a dynamic, anisotropic fluid. Just imagine a bizarre cosmic liquid filling the interior. Because the black hole is spinning, the inward pulling pressures and the sideways, tangential pressures are fundamentally different. This pressure anisotropy counterbalances the extreme inward pull of gravity, keeping the whole incredible structure stable and in check, without ever collapsing into a point of infinite density.
And the best part? This model is backed by hard data. In physics, we have strict rules called energy conditions that dictate how real matter is allowed to behave. Look at the top row of the table. In the outer interior of this spinning fluid, all the energy conditions are completely satisfied. The math beautifully holds up to standard physical reality. It's really only when you look at the bottom row, right at the very inner core along the polar axis, that we see some specific violations, which physicists attribute to the extreme nature of the inner Cauchy horizon. Overall, it is an incredibly robust, realistic model.
Section 6. Redefining reality. So we've traveled from the event horizon, through walls of fire, and into oceans of spinning cosmic fluid. The textbook view we all learned, the one on the left, is the static, dead, crushing point of infinite density, a place where physics just dies. But the modern view, revealed by the latest metrics and quantum topologies, is on the right. We're now looking at a vibrant, dynamic, fluid-filled marvel. It's a structure potentially guarded by a blazing firewall of quantum energy with an interior that is secretly stitched to the rest of the universe via intricate replica wormholes. The absolute crucial takeaway from this explainer and the source research is that we aren't just playing around with abstract math on a chalkboard anymore. By solving these metrics, we're literally bridging the gap between mathematical formalism and the actual, real phenomena swirling around in our night sky. The black hole is no longer just a cosmic eraser, it is the most complex engine in the universe. And it leaves us with this thought. If the interior of a black hole is this structured and alive, what other cosmic mysteries are out there, just waiting for the right math to unlock them? Thanks for exploring this source material with me today, and definitely keep your curiosity focused on the stars.